Hi guys, welcome to this 48th tutorial in this series of programming PIC microcontroller with MPLAB XE8 compiler. This is part 3 of interfacing SD card. In part 1, we explain the SD card connection to a PIC microcontroller. In part 2, we explain the FATFS library that can be used with MPLAB XE8 compiler to access the SD card. And in this third part, we're gonna write our code. Let's start a new MPLAB XE8 project. New, gonna be a standalone project. We're gonna use the PIC 18F 45K22. Next. Gonna name our project FATFS. Click Finish. Okay, we're gonna use MPLAB code configurator to configure our SPI peripheral. Click on Tools, Embedded MPLAB code configurator. Okay, we're gonna start with the system configuration. Switchover mode gonna stay disabled. The oscillator, we're gonna use the external HS oscillator, medium power 4 to 16 MHz because we're gonna connect an external 8 MHz oscillator. The fail-safe clock monitor disabled. The other important thing, we're gonna enable our MCLR pin, and port P are configured as digital input-output on reset. So basically we're gonna use an external oscillator. It's gonna be 8 MHz. And the next thing we're gonna do, we're gonna configure our SPI peripheral. Under MSSP, we've got two. We're gonna use the first SPI master. Click on SPI. The clock edge, gonna select active to idle. The SPI clock, gonna select FOSC divide by 64, which is gonna give us an SPI clock of 125 kHz. This SPI clock speed has to be between 100 and 400 kHz to initialize the SD card. And once the initialization is successful, then we can increase the speed. And to increase the speed, we're gonna create another initializer. So click on this positive button to create a new one. The GUI supports multiple initializers, so any number of initializers can be generated for a module based on the application requirement. In our requirement, we're gonna use two initializers. One for the normal speed and one to initialize our SPI with a speed between 100 and 400 kHz. This one we're gonna name it open. You can even write some comment here. The clock edge we're gonna use active to idle, and FS oscillator we're gonna divide by 4 to give us a SPI clock of 2 MHz. And the last configuration we're gonna do, we're gonna configure our general purpose input-output pin. Double click. Here we're gonna select our chip select pin. We're gonna use RC0 as our chip select pin. It's gonna be an output, it's gonna start high, and we're gonna name it SD chip select. And that's all guys for all our configurations. Let us generate our code. We're gonna need a main.c file, yes. Okay, let's go to our project files. You can see we've got our main.c.file and we've got our MMC generated files. The same goes to the header files as well. Let us create two logical folders to copy our FATFS library files. Under the header files, click new logical folder. Gonna rename it FATFS. And under our source files, we're gonna create another folder as well, new logical folder. Rename it FATFS. Let's copy our FATFS header files. Right click, add existing item. Let's select all our header files, disk input output, ff.h, ffconfig.h, and integer.h. We're gonna copy them to our local folder. Select. And let us copy our source files, add existing items, the ff and the disk input output.c. We're gonna copy as well so that we don't have to edit our original files. Select. We're gonna do some few modifications on these files. according to our requirement. The disk input output.h. These are the common include file for FATFS and disk input output module. So all our SPI declarations gonna be declared in this disk input output.h. We define the SPI port. This is a defined option to specify the SPI port that you're gonna use. As we use SPI 1, so we're gonna select 1. You can skim through this file and compare it with the original file and see what you have changed. These are our PIC 18 SPI definitions and functions. We said the SD init must open SPI at a speed between 100 and 400 kHz. So this is our SD init to call SP1 initialize, which is defined in the MMC generated files in the SPI1.c. This is the second initializer that we declared, SD open, and these are the functions that we're gonna use to send data to communicate through the SPI bus. The FF.h. These are the common include files for FATFS and application module. We didn't change anything in this file. It's exactly the same file that we downloaded. The ffconfig.f. These are the configuration file for FATFS module depending on your requirement. The FS read only. We selected 0 to have a read and write access to our files. FS minimize. We selected 2 to minimize to save some few memory of our PIC microcontroller. And the other thing is the volumes. We selected only one volume. Multi-partition 0. So basically you can define these options depending on your unique project requirement. And the integer, this is the integer types definition for FATFS library. We didn't change anything in this file. This is our disk input output.c. And lastly, this is our ff.c. We didn't change anything. It's basically the same as we downloaded it. Okay, let's go to our cmain file and write our code. This is our cmain file. The first thing we're gonna do is to include our ff.h library file. Then we're gonna declare some few variables. The first variable is FATFS. This FATFS work area is needed for each volume. Because we're gonna use only one volume, so we're gonna declare only one. And the fill variable, this is the file object needed for each open file. Because we're gonna open one file only, so we're gonna create only one fill variable. The other variable that we're gonna declare, unsigned int bw variable. We're gonna use this variable when we're gonna use the fwrite function. The first step, we're gonna mount our SD card using the fmount function. We're gonna use the default drive and we're gonna mount our volume immediately to check if the F volume is ready to work. And if we receive FROK, it means the fmount function was successful. We're gonna say fopen. And our file, we're gonna open test.txt. If this file is not existing, then it will be created because we use this tag fa open always. So whenever you create your file, you have to specify the extension as well. In this case, a .txt extension. We're gonna give this file read and write access. And if the file open call was successful, then we're gonna use the flseek function to jump to the end of the file to append data. Then we're gonna start writing. We're gonna use the function fwrite. We're gonna select the file. Then we're gonna write hello world. This is text message written to SD card. Then we're gonna go to the next line. Here we'll have to specify the number of bytes to write. In this case, we're gonna write 54. And once we are done, then we're gonna close our file. So let us build our project. We're gonna use the build and clean main project. The build successful. Let us load our code into our programmer. Let us load our .x file. Right, it's loading. We're gonna plug our SD card. And press the reset button. Let us unplug our SD card and plug it into our PC and check the files that were created by this program. You can see this is our SD card. It created a text file named test, and if you open this file, it's written hello world. This is text message written to SD card. Thank you guys for watching this tutorial. Don't forget to subscribe to this YouTube channel to receive more tutorials, and I'll see you guys in the next tutorial. Thank you.